ontologies. So rather than harmonizing everything, create a global namespace. So rather than harmonizing the ontology and the taxonomy of the data, start harmonizing the namespace, which means if there is an asset called Sid and if there is an asset called Kevin, so Kevin and Sid can be a global namespace, and all the attributes, the maintenance attributes, the prognostic attributes, the physics, the modeling, they can all be the sub namespaces inside the global. It's very similar to object oriented programming.
Wow, I haven't heard that in a long time. I remember that. What's interesting, I see the need to sort of incrementally approach. I think you need to get some victories in your belt. I just think that, see, this is what and prove that out. Now, for me personally, and having multiple conversations, I hear the word edge. I hear it all the time. I hear it even in my house. Can you help us understand that?
Okay, if I'm able to do that, and if there was a Nobel Prize in manufacturing, I might be nominated for that. See, edge, and again, so I can see that all the questions are very relevant. See, edge is the most misunderstood or poly-understood phenomena I call it misunderstood or poly-understood. So there is no single definition of edge, and we can take an example of any shop floor. So on a shop floor, a machine is definitely an edge, but that machine has a bill of material, and some of the bill of materials are sensorized, so that is an edge. But that machine is harnessed on a platform, which itself is sensorized and connected to a field bus, that is an edge. The entire data is going to a mod bus, that is an edge. Then there is a network control router and network address control switchgear, that is an edge. Now if you might have a 5G mech, that is an edge. And eventually if you're dealing with millimeter wavelength and ultra high frequency of 5G nature, there is a POP device, that is an edge. Your security gateway is an edge. Your multi-protocol gateways on the plant are edge. Everything is edge. So again, I think we need to define what I have started calling it, and I won't claim that it is my term, but very few people call it. I call it contextual edge. See, we need to look at the outcome and the use case, and then see what is the contextual edge for that particular use case and that particular outcome.
See, and it's interesting because you brought up a good point. You named a number of items that are edge, and they are, they're right there. But for me, in my simple mind, it was I see a shop floor, I see this box over there, it's the edge, and then it sends it up to the cloud. And that's and this edge device says, oh yeah, I'm receiving data, and that data I don't need, but this data I do need, so I'll send it.
So that's a great way of simplifying everything. But today, on a shop floor, there are multiple devices which are directly connected to either a private cloud or a public cloud. And if you look at the public cloud, AWS and the Azures, they are stepping into edge. They are bringing the power of cloud into edge. If you look at the Snowball family of AWS and the Monitron device of AWS, and if you look at Stack Edge of Azure, they all are bringing the power of hyperscalers into the edge, because edge is very important. And that is why Hitachi is building and going to launch a very new concept, which we are going to call Hitachi Industry Cloud. It will have a continuum of connectivity and use case orchestration from edge to cloud, and we are going to bring...
Go ahead, keep on going, because you're touching on something
so
there.
So we are going to bring in the crystallization of our years and years of experience in business processes and domains, templatized into libraries, data models, data architectures, and we are going to abstract the user from the complexity of where my data is getting orchestrated.
Yes.
So the user should not worry whether my data is getting involved with edge or a private cloud or a multi-cloud or a hyperscaler. So we are trying to build that concept, and that is something which we are working on.
That is an aha moment for me, because when you started rattling off different types of edge, fine. Of course, my mind goes to, well, those are all sources of possible data. And then for me, I'd want simple. I don't want to know about how the data sausage is made. I don't want it. I want that to be programmatically solved for me and then displayed in a way that makes me feel warm and fuzzy and makes me do my job better.
Absolutely. So the user should only be worried about outcomes and
That's it.
visualization and form
Yeah.
factors. Can I access it on my mobile device, handheld, tablet, and PC, and in what form and what differences? And what will I lose between my mobile device and my PC? That's it.
That's
The user should not be worried about whether my data is going to reside in Edge, whether I'm going to archive it somewhere. Oh, do I need a private cloud? Do I need to add extra capacity? Oh, I have a SaaS and a LAS and a
Yeah.
PaaS and a hyperscaler. Man, we are there to
Yeah.
worry about it. We will abstract this entire Byzantine
yeah.
spaghetti for
That's
you.
it.
Yes.
It's spaghetti. I don't want to see that. And if I'm in manufacturing, I know that I have all these data. I don't want to see all the sausage there, or energy, or transportation. The same thing exists
Same thing in different
across
ways.
the board.
So different. So in every industry, there is something new which is happening. I took a small example of manufacturing. You go to utilities, the entire grid is unidirectional, generation to transmission to distribution.
It
But
is.
now there is an element of bidirectionalism
It
coming
is.
in. So
It is.
there is no device which is completely geared towards a bidirectional grid. So the grid of the future, the renewable grid, the green grid, would
The
be
smart
bidirectional.
grid.
The smart grid.
Yeah.
It will be bidirectional.
Yeah.
Now, to make it
Yeah.
bidirectional, you need devices and you need the sausages
Yeah.
in the way which are bidirectional. So the sausage factory
Yeah.
should again be abstracted from
Yes.
the user and prosumer.
That's brilliant. And you don't have to come into a company or an organization or a manufacturer and say, hey, you're going to have to implement all of this stuff. No, we're going to extract, reveal the data that is necessary to make you a success, create that business that is resilient, whatever it might be. And we're just going to compress the time to data, to visualization, and then you can do your job, be more optimized, whatever it might be, whatever the term is. And that's across the board, and that's with everything. But that whole
Everything.
utility thing,
Yeah, the
that's
utility.
way above my pay grade because
Utility is beyond all our pay grades because
God.
it's a federal thing, it's
is.
a geopolitical
Oh.
thing. Look at what is happening in Ukraine and Russia. The entire war is creating an energy crisis in Europe. Now, see, if Europe keeps itself hyphenated with fossil fuels from Russia, then they are going to keep running into a very high electricity bill because Mr. Putin. But the point is, if Europe is able to dehyphenate itself in the right time and in the right ways and modernize its grid and look at green hydrogen, look at renewables, look
Yeah.
at its
Yeah.
own self-sustaining
Yeah.
atomic and nuclear power, a Fukushima disaster should not be a reason to shut down all the nuclear plants in Germany.
super thumbs up on that statement. Absolutely. Now we also I want to roll in digital twin. Now, where does digital twin play in all of this? Great
Digital twin
conversation?
is, I will say it is a very close cousin of edge when it comes to complexity in understanding. So people understand it in different ways, but see the way we in Hitachi interpret and understand digital twin is a model which replicates real life. And the relative distance of time or the relative delay in time between the real life and the model needn't be real time. It totally depends upon the use case. So a digital twin can be even a 30-minute delayed digital twin. If the use case can tolerate 30 minutes of delay, or the digital twin can be a microsecond delay if the use case cannot tolerate that more than a microsecond of delay. So the use cases which govern digital twin are basically mission critical simulation.
Very good.
So if you're running a very high speed train and the wheelbase of the train needs to be digitally twinned at perhaps a microsecond, the signaling systems need to be digitally twinned at a second. And maybe the rolling stock, the carriage and the HVAC can be digitally twinned at a 15-20 minute delay. So digital twin is basically watching and observing real life from distance.
So the reality is, Sid, if I need to get a hold of you and I need to be able to say, hey, I don't want to see how the sausage is made, the data sausage. I'm going to go to the data sausages king, and that is Sid. How do they get a hold of you? I mean, if they want to get a hold of, they're listening to this and they're saying, I hear what Sid's saying. I want to be able to get a hold of him.
So Sid is a part of a very large community of some very brilliant people in Hitachi Vantara, and I would like everyone to be invited to our labs, our innovation labs, which are in Santa Clara and which are in Detroit and Pennsylvania
Excellent.
and Dallas, and reach out to me. Mail me, sid.sharma@hitachivantara.com.
There you go. All right. Thank you very much, Sid. Man, that was great. I love that. All right. Thank you very much for joining IMTS Creators Lounge. This is Sid, company's Hitachi Vantara, and definitely you need to tap into that data. You need to figure that out. Make that a priority. Thank you, Sid.
Thank you.